Good day, internets. In this video, we will be looking at this MSX HX-10 by Toshiba. Untested eBay purchase, £25, sold as not switching on. So we're going to do basic tests on the power, see what we find, and then follow through with more diagnostics. There are no dead tests for this, and you can't run any diagnostics until you've got a working system, unfortunately. This system has no schematics that I can find. This has a couple of chips in which are quite specific, mainly the MSX engine. It also has the TMS graphics, which you can find if you are happy to pay the price for it. Then it's Z80 based and very similar memory to the Spectrum and all the old 8-bit systems, so they should be okay. So let's unbox this system and have a look through my fault finding process. So here we have the parcel that came by Hermes. Thankfully, I know the Hermes driver, so it got here while I wasn't in the building. So here we have the Toshiba HX-10 64K. It's very dirty, it's kind of white instead of grey. Let's just quickly try a kitchen wipe. Okay, so that's pulled plenty of dirt off, so I think a good scrub on that and the plastic protector that I've got should do a good job of bringing the colour back on there. Alright, that's had time to dry, and there's a few stains, but overall it looks better, so that just needs a really good scrub. First thing I want to do is check the fuse in the plug. It all looks good. So let's just do a basic buzz test. And the fuse is good. That is step 1 on the checklist. I'll just pop the screws out of the case and then we will look inside. Let's take the top off. We have some connections down here for the keyboard. The keyboard looks okay. No sign of corrosion. Let's put that away for the second. Here we are inside. A little bit dusty. We have a transformer. I believe this is the PAL module and our main board. Before I switch this on, I want to test the output from the power supply, which is coming in on this Molex connector. So we can just pop that off and check that we actually have voltages coming out. So it says 240 volt, 8.5 volt and 16 volt. Because we will have no load while doing this initial test, it will be higher than that as long as it's not too high. So maybe 10 or 11 volts and 18 or 19 volts. That will then go through the rectifier circuit on the main board. As long as it's not crazy high, we should be okay. On the silk screen of the board, it lists AC1, AC2, and it says at the top plus 12 and ground. So I'm going to treat those as the two circuits. And then on our power supply, we will put it on AC volts. I'm going to plug it into my RCD, so if there is any major faults or shorts, this will trip. We also have a power switch just there. So if we get nothing on the Molex, we can go to the power switch. So we're set up for AC volts, we're plugged in to the first two circuits. We are switched off at the switch, so I'm going to turn on my trip. And now let's turn this on. So we have 10 volts. So 8.5 up to 10 is okay once we get a load on there. So we know the switch is working, we have a lower voltage. Now let's go to the other pair. So this one should be the higher voltage, 16, so we may be looking at like 18. So yeah, 19 to 20. Again, once we've got a load on there, that will drop. I feel happy enough to plug this in and do a power on. Once we do a power on, we can pick a chip, let's say the Z80, and check for the presence of voltages. And looking at this, we have 4116 memory chips. So that's another good way to check, because that has +5, -5 and 12 volts, I believe. I'm going to connect up the keyboard because it has two LEDs on there which we can use for diagnostics. Okay, power on at the trip switch, power on at the MSX. We have a red line for power. So one thing that I looked up was that the caps lock key is supposed to flash. So caps lock is not working, therefore the system is not working. I think it's also Control G is supposed to make a sound. So from this we do have power, but the system isn't running. Now we need to do some probing to actually find out what is and isn't working on this system. After talking to Noel from Noel's Retro Lab, this HX-10 does not have a schematic. So I can't go to something that will tell me where everything is. We're going to have to use known parts on the board to check for functionality. Looking on this, we have a Z80 CPU. I believe this is the mask ROM. This is the TMS graphics chip. Yamaha sound chip. This TCX1007 is like the Commodore PLA. So this is the MSX brain, and it does all of the switching. It's basically a unified logic device. I don't know if that is specific to the MSX or specific to this particular one. But that is, if that is bad, we're kind of done unless I can find a spare chip. I believe that these are the main 64K and these are the video RAM. So before we connect up a TV to see what's going on there, I want to do some more voltage measurements. We know that the system isn't running, mainly because the caps lock light isn't doing anything. And the page from TimeMaster Software that I found said that that is basically not going to work if the caps lock isn't flashing. Let's have a quick look at the tools that I'm going to be using while trying to repair this MSX. So we have a multimeter. This isn't a particularly good one. It's obviously made to look like a fluke. I saw this on AVE. It's okay, does the job. It's got quite a lot of functions on there. DC volts, AC volts, resistance, diode, LED, capacitance, frequency, temperature, and it can also test transistors. Not that I've ever done that. For this testing, we will be mainly using AC and DC. We've already seen that we've used AC to test the transformer output. So then we'll use DC to check the voltages of chips. We could use the frequency to look at the frequency of the processor. If it's not clear enough, we can go to an oscilloscope. So that's what we'll be using on a basic multimeter. Another very useful tool is the digital logic probe. You can get new ones, but this is an old one that I brought. Made by Philips. This will allow us to probe logic on these chips. So we could look for high volts, low volts, and activity. For example, we could plug it on, we could probe the outputs of the memory chips, looking to see that they're doing something. This is powered by clipping onto some point on the board with ground and 5 volt. So it's using the same base voltages as the system. I then have one of these cheap component testers that you can get on many places. This is a really old one. So this could be used for testing capacitors, resistors, diodes, transistors. You just plug something in to the sockets, press the button, and it will try to identify it and test it. I then have a logic testing device. Again, it's a cheap thing that I got on eBay. It tests most of the 74LS logic, so it's quite useful for getting a quick diagnostic. Unfortunately, it can't do memory, and not many can do the memory that we've got on these boards, especially these, because of the various voltages. And then really what everybody should have if you're doing anything on old retro systems is an Eprom programmer. I have this TL866. This is good for many modern devices. And I also have this GQ4X4. So this one, I think these two can both do pretty much the same. This one has the advantage that it has an auxiliary power input. So we can program older devices that needs 25 volts. That's why I ended up buying this one after buying this one. So this is very useful for that. Both of these are still currently supported. This one is about £100, I think, that I've seen. I don't bother buying all the adapters with them. The other thing that the TL866 can do is also testing logic chips and some memory. So if we wanted to double check that we not think that this is working right, we could also check the logic chips in here. So a very, very good tool for testing old retro stuff. A new tool that I brought is this old memory tester. And again, there's quite a few of these that you can find. If you see the video again from Noel's Retro Lab, he looked at a few of these. This one can do quite a few different types of memory, and it has good activity on the LEDs telling us what's going on. I can test both of the RAM chips in this MSX using this device. So I'm going to test the 4116 chips using this diagram from L Breaking Two Program's excellent Spectrum site. We can see that we have ground, minus 5 volt, plus 5 volt, and 12 volt. So testing this chip should give us a good indication that all our voltages are present. I'm going to set my meter to DC volts on the chip. Pin number 16 is ground. Pin number 1, negative 5 volts. This is turned off at the moment, so we shouldn't see anything there. Pin number 12 should be 12 volts. And pin number 9 should be positive 5 volts. So I'm going to switch this on, and then we can measure those voltages. So switch it on. Get my hands out of the way. So ground. So we have minus 5.2, 12.3, and 5.05. That means that the memory is getting the right voltages. Let's check the voltage, the chips to the side. And I believe this is more like a TTL 74 series with just the ground and the 5 volt. So on these, let's switch it on. So we should be seeing 5 volt, and we are. I don't want to leave it on for too long. Now we're going to look at the Z80, and it is pin 11 is 5 volt and 29. Those two pins. And we do have 5 volt on our Z80. I'm happy that the main chips are receiving the correct voltages. I think next we should connect up our television and see what we get on the screen. We know that it's not running, but let's just do that anyway, because it would be the next logical step. Alright, got the trusty old LG Flatron. This MSX has composite video and audio on the back, as well as RF. Switch the TV on. Let's turn this on. If we don't see a picture, we could at least see that the TV thinks that it is receiving a signal. I believe the TMS chip will output a signal if it's receiving the right clock coming in. And it does. So the TV has changed, showing us that it thinks it's receiving a composite signal. We could confirm that with the scope. Got the scope connected up, just plugged into the composite output. When we turn this on, we should see what looks like a TV signal with a sync pulse with a low at a set distance, and then something in between. We're not really going to see anything that would be meaningful in between because we're not getting any output. We can see a dip. So if we roughly set the cursor between our 2 points, the timing between those 2 points is 50 Hertz. So that's not a coincidence. That says that we have a 50 Hertz signal going out of the composite. So the TMS is indeed outputting a signal to the TV. So while we have the scope set up, we could look at the clock on the CPU. So looking at our diagram, the clock should be on pin 6. So I've got the scope set up. We want pin 6. 1, 2, 3, 4, 5, 6. So we have a nice square wave, and the frequency on the scope says 3.577. I'm happy then that our Z80 is receiving a clock. If we look along the other pins, we've got address and data. So we could just quickly look at activity on the address and data lines. It's definitely doing something. If the processor's not running as it should do, is it because it can't execute the code? Is it because it can't get the code off the Eprom? Or is it that the memory is not working properly? And unfortunately, there is no diagnostic dead test cartridge for these systems. So what I can do is just look at the memory, and it's easy to look at the outputs of the memory to see what's doing. Let's test this memory chip that is in a socket, because then if I find that it has a problem, I can then test it. Going back to our pin out, pin 14 is data out. So let's have a look at pin 14 to see if we do have data coming out of the memory. So pin 13 is the third one over. So that chip has activity, but this chip doesn't. That chip is low. Activity, low, high, low, low. Not all of the video chips have activity. If we test the main memory, I'm not quite sure. Some of them look okay. Like, that doesn't look right. But that one does. So again, it's going along the lines of it's not executing code. Let's go back to this one that's in the socket. I'm just going to turn it on and off a few times. Now, see, we have very small glimpses of activity. If we turn the trigger up, let's check the others. So that one's doing something, but it looks strange. So those chips are doing something different to the first time that we turned it on. And now it's gone back to doing nothing. So is the memory faulty, or is it just not being told what to do correctly? As we have this one in a socket, let's pop that out and run it through the chip tester. This is our tester, and we want to be using this first socket for the video RAM. We don't want to use any other types of memory apart from the 4116 in here, because this one supplies the 12 volt and the minus 5 volt. Pop it in our tester. So we can see that it's flashing while it's testing the memory. And we have 4 blue LEDs. And if we look on the instructions, 4 blue LEDs means a pass. So this chip that was failing and not working properly in that socket is actually a good chip. So this is again pointing me towards that the chips are okay. Obviously there could still be problems. I don't really want to go pulling them out, but until we can get something booting on the system, I'm going to take it that the chips are working and there's something else that's wrong with the system. Following on from the timeout software guide, obviously it could be any of these chips that are still faulty, but it looks like it's executing code and the code is random. So if the code is random, it's memory or the Eprom. Maybe the code in the Eprom is not right, and that was what the timeout software blog was talking about. It was saying that the Eprom was corrupted and it was stopping the code from booting. Again, we have no dead test or diagnostic cartridge that we can plug in that will bypass the Eprom. All the ones that I've actually found all use operating system calls, so I can't plug something in and bypass it and do testing, unfortunately. I'm going to find an Eprom for the HX-10 and I'm going to program it and see what happens. So let's quickly look at programming an Eprom and then doing a comparison test. So here we have our Mini Pro, and based on what the timeout software said, we need to be using 27256 devices. And just use the generic device. And now we should be able to read the mask ROM that I've got in the Mini Pro. Oh, we need to make sure that we turn off pin detect and check ID. So this is the code that we have read in. So there's definitely code there. Yeah, and so there we can see some English. So there's definitely some code there. So next we want to open, and if we open a good working file, yeah, so MSX10 HX-10 BIOS.ROM. So this is the BIOS for the HX-10. So our buffer now contains the correct file that should be in this mask ROM. So we can now do a verify, and it will verify the ROM on file against this chip. And here we found a problem. So the contents of this mask ROM do not match the contents of the original file. And there are multiple faults on there. So I think that the problem that we've got is this mask ROM is just bad. I have some Eproms that we can use. So I'm just going to, just to be safe, open this ROM again. I'm going to do a blank check. It says that the chip is good. And then I'm going to do a program. So that's just programming along. And it's verified against the code that we have on file. Let's take this back to our HX-10 and see what happens. We are back at the MSX. I've got the TV set up again. Here we have our Eprom that has been programmed with a new copy of the ROM. So that just pops in. I haven't covered a window yet. I will do that eventually. So let's see if this has fixed our problem. Wait, look at that. We have a picture. MSX basic version 1, 28815 byte 3. Awesome. We've been really lucky that the problem so far has just been that the mask ROM was bad. The programming a new ROM has brought this MSX back to life. Wow, it could have easily been so much worse, having to hunt around trying to find chips like the video chip. Z80 not too bad, the memory not too bad, but we still have to find ways to actually test the system is working. I'm just going to quickly plug the keyboard back in because we can at least check the keyboard's okay. Right, keyboard is back on, power on, caps lock light is working. I believe it's Control G, if you can hear that. Just hear the beep. So that's awesome. Wow, I'm so happy it's actually booted up. We can't just leave it here. We have to find ways to actually test the system. And I spent quite a lot of time looking, and there are some programs that you could run, but a lot of the programs were designed to run from disk. Obviously I don't have a disk. Could get cassette working. I don't have a lead. I could try to make a lead up. The programs that I found came with the option for cartridge, and I was looking around, and just so happens that I found a design for an Eprom based cartridge which was open source. It was free to use. I could order some circuit boards, and then I could burn some more ROMs with some diagnostic tools so that we can check more functionality of this MSX. While I was doing this, I was asked by PCBWAY if I wanted to work on any projects with them. I've worked with them in the past on my older channel, and I said, yeah, I've got an MSX, I need to get some diagnostic cartridges up and working. Can we work together? And they said yes. So I uploaded my files, and a few days later, I think it was 4 or 5 days, a parcel arrived from PCBWAY. So thank you PCBWAY for sponsoring this video. PCBWAY are so helpful with so many retro inspired projects. They do the best quality circuit boards that you can find. I didn't go for anything too fancy, but they could have been gold plated with the chamfered edge to make the cartridge easy to go in. PCBWAY now also do 3D printing and CNC. So if you don't have access to a workshop like I do, PCBWAY can make your circuit boards. They could make your 3D printed or metal enclosures so that you could get the whole project going. They could also do surface mount. Please go and check them out. I'm sure that you've all seen them before. Like I said, they're so helpful with so many other channels. Thank you PCBWAY. Go and check out their website. Order your circuit boards, 3D printing, and now CNC. So the next task that we've got in this project is to make up some diagnostic printed circuit boards. I have two programs that we're going to be testing. One of them is a diagnostic program, one of them is a memory test program. The diagnostic program is by Nightfox & Co. I'll put a link to the website where you can get the files. You could actually buy a cartridge in the description. Like I say, these cannot be run without a working ROM in the system because they use OS-ROM calls. So they can't be used to diagnose a system that isn't working already. So let's pop in the EPROMs that I've programmed into our cartridge and switch them on and run through the tests. So here we have the first one, which is the diagnostics, into our cartridge, and we're just going to pop that in there. On these, the EPROMs face forward, and then we'll switch that on. This is the diagnostics program that I found. And this is from nightfoxandco.com. You can get this on tape, you can work from floppy, and as we can see, it will work from the cartridge as well. So again, this is cursor keys or joystick, press space. So let's work through these. We have screen tests, screen test 0, so I believe these are the modes of the MSX. Press right and left to change the text color. Press up and down to change the background color. Press accept to restore defaults. I'm not sure what accept is. So we have white text, and we can go through the colors. We can change the background. So screen 1, same deal. So now we have some more graphical test patterns. So I think we can change the background. Screen 3. Okay, so it's not reporting any problems, everything looks okay. Let's move on to sprites. Press accept to start and stop sprite movement, press up to reset positions, press cancel to go back to the menu. Accept is space. So that looks like it's okay. We can press up and start and stop. So you can see that there are some points where it overlaps. I believe that's where there are too many sprites on a single line. Right, monitor color. Press left to right to change the color, press up down to change the speed if available. Black test, red test, although it's more of an orange. Green test, blue test, looping test. Let's go on to the next screen. So we have keyboard check. Press and release the key to test. When a key press and release is detected, you'll be rewarded with a text, color change and a sound. Press Shift and Escape or button 2 to go back to the menu. So F1, F6, F2, F7, F3, F8, F4, F9, F5, F10, stop, insert, delete, select, home, escape, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, underscore, plus, / BS, tab, Q, W, E, R, T, Y, U, I, O, P, left parenthesis, right parenthesis, return, control, A, S, E, F, G, H, J, K, L, semicolon, speech mark, squiggle, Shift, Z, X, C, V, E, N, M, left bracket, right bracket, question mark, Shift, pound, caps, graph, space, code, cursor keys. So I am happy that the keyboard is working very well. Joystick. So I've only got the one joystick plugged in. Test the direction of the 2 buttons. Color of the indicators will change if press is detected. So I've only got the one joystick plugged in, but that is detecting just fine. So PSG, which I believe is sound, up and down to change the option, left and right to change the value. So we have channel A, 300 Hz, 500 Hz, 1 kilohertz. Channel B, C, we should be able to change the volume of channel A. And then we have noise, channel A, channel B, channel C, and we can change the frequency. So that looks like sound is okay. Mix mode is something that certain MSX have, I believe. You must see the 3 text blocks if your VDP supports mix mode. You must see me 3 times. You must see me 3 times. You must see me 3 times. So that looks like that is working. System info, MSX, keyboard GB, 64K RAM, TMS 9929A, 16K VRAM, frequency 50 Hz. I'm not sure about the block below. That could be extensions that are plugged in. RAM layout. So these are all the slots that the MSX has. You can extend it by quite a lot. We are using slot 2, page 0, 1, 2, and 3. And then we can reboot and go back. So this is a memory tester. As we can see, it says that the Mega RAM is not found and the memory mapper is not found. We have an MSX1 at 50 Hz. We're using 64K of RAM and 16K of video RAM. If we test our base RAM and space to select, so it's testing the first bank and the second bank, it says HO failures. Press space, but there is a tick. So I'm taking it that that is no failures. And then if we do our video RAM, it's checking pages of the video RAM. And again, we have a tick. It says HO failures. Press space. So after all this, where we had the problems with the memory that looked like it was doing some random stuff, it was definitely the Eprom not executing code properly. Our memory has tested okay. I think this is a fully working system, as far as I can tell anyway. So really what we need to do next is give it a good clean. So let's move on to the cleaning montage. we are down to the last steps of cleaning. So we've scrubbed the case, we've cleaned the keyboard, we've treated it with something for the plastic as well. Admittedly, it's just dashboard stuff, but it would be enough to at least give it a coat. Keyboard cleaned up really nicely. The case still has a few marks that I couldn't get out because I didn't want to scrub, and some melted bits, but overall it looks really nice. So just connect that back up. Yep, everything is connected up. So now it's just the last screws. I seem to be missing one. Oh, that's annoying. I thought I'd kept everything. I'm missing a screw. So it looks like it's an M3, so I'm sure I can find something. And here we are, after a sweaty afternoon in my hot workshop. This is the result. Our Toshiba HX-10 64K MSX computer is looking really nice. So let's get it connected up. In the process of making all this, I actually found a cartridge that didn't cost £1,000, slight over exaggeration. So we can actually plug something in and play a game of some sort. Let's get set up to do that and we'll take a look. This is the game that I found. I'm not quite sure what it's called. After looking on eBay and looking, they were all £40, £50, even more. This one was £20, so I just grabbed it. I just wanted to get something that we could actually test. Just slots in, we turn it on. So, exchanger. I have a feeling this is a two-player game. I have no idea what's going on. So yeah, at least it's a game and it's working. So that's the end of the repair. There's one thing that's left. I wanted to know what was going on with the Eprom, if there was some fault on there or what the fault was. So I asked Dean, Breaking to Program, who has been building his own MSX and knows more about Z80 than pretty much anybody else that I know. I asked him if he would take a look at the ROM, do a comparison, see if he could find what the code was doing and why it was giving such a random result when I was testing the memory. He did find some patterns, he did find some problems, and he's made a small clip. So let's take a look at what he found when he was going to take a look at the ROM, disassemble it, try and work out what it was doing.
He popped me a PM on Twitter a month or so ago, asking me whether I'd be able to help investigate an issue he was having with an MSX. It wasn't booting on his original ROM. yet was working fine on a new image blown onto an Eprom. Clearly, there was an issue with the ROM, but where? He supplied a couple of ROM images, one taken from the original ROM, which I've labelled dead ROM, and a known working image, which I've labelled good. The first step is to determine how many differences there are between the ROMs. This assumes that both ROM images are the same, albeit one with potential faults. It would throw up false positives if I was comparing the suspected bad ROM image with a different version of ROM. I'll use a command line utility for this. On my Mac it's compare. Though it's possible to do this on a Windows PC using the command FC with an argument /B to tell it we're comparing binary files. So let's run that now. -L for verbose. I'm only interested in looking at the differences and the two files in question. So I'll put the dead ROM in first and compare it with the good ROM. Okay, so there are a lot of differences. Let's have a look here. There's a significant number of differences here. Let's scroll up to the top quickly. Okay, it seems to be going in blocks as well, so we're in the 18,000s and it skips to 16,000, 13,000. It's interesting to note the differences between the values as well. They seem to be 4 out. So you can see here 2050. The good ROM contains the value 10 and the bad ROM 14. Okay, so let's take it to the next step. What I'm going to do is disassemble both these ROMs and let's have a look at them in more detail. I'm going to use online disassembler to get a text disassembly of both these ROMs. And then I'm going to compare them in Visual Studio Code. So let's start off with the suspected dead ROM. Upload the file. Let's choose the dead ROM. I've got to tell it the architecture. Scroll down to Z80. Base address is good. I'm not sure whether I'll go for little endian. Z80 is little endian. That means when it's storing a word, it stores the low byte first and then the high byte, as opposed to big endian, which is the other way around, storing the high byte then the low byte. Let's import that. We can ignore this error. We cannot identify the entry point to the executable image. Well, we know the entry point is a Z80. The entry point is 0. And we have a disassembly. There we go. Disable interrupts. Jump to an address. This is looking plausible. The Z80, the first 56 bytes or so of RAM are dedicated to the restart instructions. Restart 0 is the entry point, so the first thing this machine does is disable interrupts and then jumps to that address. And then we've got restart 8, restart 16, and so on and so forth. And it looks like we've got a bank of, it'll be a lookup table, a list of vectors to other parts of the ROM. Yep, that's looking plausible. So let's save that out. Download disassembly. Let's drag that over there. And do the same for the good ROM. Load file. Rinse, lava and repeat. Z80. Little endian. Ignore the error. And again, at first glance that's looking pretty similar, isn't it? Okay, let's save that out. Rather good utility this, it just saves you installing a disassembler on your computer. So let's get Visual Studio up and running. Where's that? There we go. I am going to open a folder, which is the folder these ROM dumps are in. There we go. And I'm going to use Visual Studio to show me the differences between these two files. And the way you do this, you open the folder, click on the two files you wish to compare, you right click and compare selected. And there we go. We've got dead ROM on the left and good ROM on the right. You can see here it's highlighting the differences between the ROMs. We've got a map on the right hand side here, the differences. Let's have a look at these. So let's scroll up to the top first. There we go. So we have no differences at the beginning. This is all looking like plausible Z80. Like I said, you've got the restart block. You've got a load of vectors there to various parts of the ROM. It's fairly standard practice, that. A load of knobs. That's a bit wasteful. Let's scroll down to the first difference then. Let's have a look at the code. There we go. So bearing in mind the good ROMs on the right hand side. On the right hand side it's looking more plausible, to be honest. You've got a push and a call and a pop. So you've got a balanced push and pop. Decrementing a loop counter BC, load A with B, A with C or with B. So that's checking whether BC is 0. And jump relative, if not 0, to 819 here. So we've got a loop by the looks of it between here and here. So 819, popping a register, outing it to a port, pushing it, doing a loop until BC 0, decrease BC, is it 0? No, then jump back to 819. So that's looking fairly plausible. At the end we balance everything by popping AF off the stack. So that looks like it's balanced the stack, balanced the books on the stack there. Push at the beginning, a pop and a push in the loop, and a pop at the end, and then a ret. That looks like plausible Z80 to me. So let's have a look on the left hand side at the same piece of code. Right, so we're going up to about 824, so about here, say. Start off, push, that looks fine. Calling the same routine, then we're pushing the accumulator again, doing a restart 10, doing a subtract, pushing the accumulator again, doing a rotate. Load A with L or with H, increase H. I mean, this looks like gibberish Z80 to me. On the right hand side, this looks like good Z80. This is the kind of stuff I'd write. This on the left, it looks plausible at a glance, but actually, if you follow the logic through, it's gibberish. It's not balancing the stack. Looks like it's checking whether HL is 0, but then you're increasing H anyway, so you're destroying the flags that have been set up here. Yeah, this looks like gibberish. I can see why the ROM on the left's failing anyway. And there's more examples of this as you go through. I think I've seen enough just looking at that little bit of code there, to be honest, to realise why this code wouldn't work. So in summary, the corrupt ROM's just running random instructions in places. It starts off looking quite good, and then just starts running gibberish. What will probably happen is it will just either call a random memory location and just crash the ROM, or the stack will become imbalanced and it'll try and do a call and then a ret with an imbalanced stack and then returned to a random place in memory. It's just not going to work at all. So that's it. That's how you compare ROMs. It needs a little bit of an understanding of Z80 probably in order to do it properly, but there we go.
So thank you, Dean, for taking a look at that. That's very helpful. At the end of the day, I was very lucky again with another untested eBay purchase. This one was saying that it didn't power on, but it was just a blank screen. And thankfully, the blank screen was a result of the Eprom and not one of the chips that is hard to find. Thank you for watching this video. Thank you to all my subscribers. I will try to do more content as they come along. Working on the CNC, as you may have seen, I'm getting close. So I will try and find a project to incorporate the CNC, making something. And I will see you all on the next one.